Hey everybody, welcome back to the channel. Today we're going to make ourselves a custom brazed tip carbide threading tool. These are the materials we're going to use to make it. I've got some 1/2 inch key stock and I've got a plate of carbide, approximately 1/8 by 1 inch by 3 inches long. The reason we need to make this tool is because I have this shaft I want to make and I'm going to be working on it between centers and pretend this is the tailstock and pretend this is a thread. Well, my nice indexable tip tools, they'll interfere with that tailstock. They won't fit in there. So I want to make something more along the lines of this that will fit in there so I can cut that thread and clear my tailstock center. You can buy a similar type threading tool with a carbide insert already brazed onto it. But what I find is because there's no rake of any kind on this, the chips will want to kind of pack in from both sides, kind of weld onto the point. Next thing you know, you're carving a big old snowball of steel through the bottom of your thread and it just turns into a mess. I'm going to put some nice rakes on mine. Now we did mention a new machine slash tool. You guys decide if it's a machine or a tool, but we'll go over that when we actually need it when we're at that point in this project. So let's get right into it. For now I'm going to start by cutting my key stock off to length. I've got my key stock cut to length here, and what I want to do is put some relief in the steel because I'm going to be grinding this shape in the carbide when I'm done, and I want the steel to be underneath, you know, kind of like that. So it's giving some support, but at the same time has clearance. So I'm going to cut these angles in here, and I'm actually going to do that in the tool cutter grinder. Now you could do that in the milling machine, but these are going to be compound angles, and that would be quite a bit of complicated setup in the milling machine, whereas on the tool and cutter grinder, you'll see it's quick and easy to do compound angles. I've got this first setup done and ready to go. There's going to be 3 setups to actually preparing this steel piece of key stock to become a tool bit. This first setup, I'm going to do 30 degrees on this side with a 6-degree clearance angle this way. And then I'll do another setup for 30 degrees on this side, again with the 6-degree clearance angle. And then I'll put the seat in the top where the carbide is going to be soldered in, and that's going to get a slight relief in 2 different directions. We'll talk about that more when we get there. You can see I'm hitting more at the bottom than the top, and that's going to be my 6-degree side clearance angle, and then the 30-degree angle, of course, is what we're grinding in this way. Just dressing my wheel from time to time because it's dished on the inside, and as I grind with it, it gets flat, and that flat gets wider and wider, and eventually you're causing more heat than you are removing material. You can see that's getting hot, and it doesn't matter. That's mild steel. Heating it won't weaken it, won't harden it, won't do anything to it. It's still going to just be mild steel after I'm done. There's my first setup done. I'm going to make setup number 2 pretty much off camera. I don't think you guys are interested in that, but I'll show you once it's all set up and I'll explain what I've done. Here's setup number 2 ready to go. I'm 30 degrees the other way and 6 degrees the other way. So I'm 30 degrees down here, and I'm the opposite 6 degrees here, and now I'm ready just to bring this side in until I get to a point. So we're done with setup number 2, on to setup number 3. What I'll do is I'll get that all set up off camera and then bring you guys back in, and I'll explain what we've done and what we're getting ready to do. I've got this third and final setup for this part of the project done, and I want to explain it here. Well, what's left to do is dress my wheel, so I'm all set up to give my wheel a dressing and make this surface nice and flat. And then I've got this thing set so that it's tipped. Well, first of all, I'm going to be cutting right-hand threads with this tool. And so it's going to feed in at this angle at the 30 degrees. And so this side is doing all the cutting. And I explained before, I don't want chips from both sides like piling up. And this side will be scraping, so there will be some stuff going on, but I want a real nice clean cutting action on this side. So I've set this up to give me 3 degrees relief in this direction and 3 degrees relief in this direction, so that from both angles that this is working, it's going to be kind of scooping and making a nice chip flow. Ready to start cutting now, and what we're going to do is we're going to grind back to this line. That's where my carbide inlay is going to end. And what you're going to notice with the 2 different rakes on here, it's going to start by grinding right on this corner, and then it will gradually work in both directions, and then we'll bring that down approximately 1/8 of an inch to give us the seat that's the same depth as the thickness of the carbide. Now that I'm just about cleaned up here at the point, I'm going to set my hand wheel, my graduated hand wheel on my depth so that I know how far I'm actually going. So there's that setup done. I'm going to tear all this apart, and we're going to get ready to start cutting up the carbide. Now, I have played with cutting carbide an awful lot, and I feel I have some important things to share with you guys on that. Just quickly before we move on, I just want to show you guys those 2 rake angles. I've got the angle in this direction of 3 degrees, and then I've got an angle in this direction, again, of 3 degrees. Close to being ready to start cutting up our carbide, there's a couple things that I think are super important that I want to show you first of all. Now, the first thing is, you can see here, I've slowed the speed of the machine way down. I mean way down. It's super important with diamonds that you go much, much, much slower than you ever would with an aluminum oxide wheel. And if you trust me on one thing, trust me on this. Slow your damn diamonds down. If you have a book that tells you they're supposed to go thousands of RPM, it's lying to you. Don't do it. Now, my experience comes from grinding dry on a tool and cutter grinder. I don't know about submersed in oil, CNC, any of these things. That's not where I'm coming from. But if you're grinding dry on this sort of tool and cutter grinder or something similar, slow your wheel down. The next thing I want to point out is you might think you could just get your wheel going and start, plunging into it like this. And we've discussed this before in other videos, but if you haven't happened to have seen those, grinders hate the plunge. Only plunge is a very, very last resort. It's going to be hard on your belt. It's going to heat your motor up. It's going to be hard on your diamond wheel. It's just going to be hard on everything. So avoid plunging whenever you can. What we do want to do when cutting up this carbide is we want to go back and forth pretty quickly and a very slow down feed. Nice slow down feed, lots of back and forth, nice slow down feed. And if we hear any sign of our belt squealing or our motor working too hard, we're just going to slow our down feed and we're going to up our back and forth game. I do have the carbide plate here kind of roughly dialed in. I've just gone off the graduations on my fixture, so it's close. It's not going to be perfect. I did dial my wheel spindle in exactly. I mean, it's been dialed in exactly this whole time, but now it actually matters more than ever before, because what we don't want our wheel doing is dog tracking through that groove. It'll just be removing a whole bunch more material than it needs to, and it won't do anything any good. Before I forget to mention it, this diamond wheel that I'm using is 1/16 inch wide, and it's got a 1/4 of an inch of height to the diamond on it. This wheel is one I bought specifically for cutting off carbides, and with all that, well, the thinness really helps you remove as little material as possible, and the height of that diamond on there is going to give you a ton of wheel life. I believe this wheel is 120 grit. So I've got this piece of carbide cut to the length I want now, and now I'm cutting it to the width that I need. And this whole setup is going to be a little bit sketchier. You can see I'm only catching it with one of my clamp down screws, which makes me a little nervous. So what I have done is I've got my wheel super close to my fixture. That'll minimize the torque that the wheel has, trying to pull that carbide loose from its mounting screw. I'm also still cutting in the direction towards my dust collector, which is going to be pushing the carbide up against the back wall of the fixture. And all that, along with me going very carefully, is going to prevent this thing from crashing. And by crashing, I mean if that piece were to cock in there when I'm halfway through the cut, potentially that could ruin my diamond wheel, which would not be cool. Next thing I'm going to do real quick is, you can see after cutting this blank off, there's some real thin, kind of nasty little burr type things on here. And the reason is that this surface inevitably becomes round after not very long of use. And so the wheel grinds through before it makes it all the way to the edge. So I'm not going to get crazy fancy here, but I don't want these strange edges faking me out as I solder this on. That'll affect my accuracy. So I'm just going to hand bomb these raised edges off on this diamond wheel here. These are really thin. They're going to come off really quick and easy without any real heat. So I've taken the worst of this one off, but this particular edge needs a bit of a special treatment, and the reason is it's going to be sitting in this corner of the seat that we've prepared for it, and this seat was ground out with an aluminum oxide wheel, and aluminum oxide wheels refuse to keep a square corner when they're grinding up against the face. They'll radius themselves very, very quickly. There's always going to be a radius in there when you're using an aluminum oxide wheel, so I'm going to put a nice healthy chamfer on that edge of my bit. Now with that small chamfer on there, that's going to sit really nice and flush. It's going to sit all the way down flat on the bottom, which I want. It's going to sit all the way to the back, which I want. So that's just about right. So we're really close to being able to solder these together, except there's an issue. There's grime and fingerprints and all kinds of nastiness on both of these surfaces. If only we had some way to clean them properly before we solder them. Well, that brings us to today's new tool. Machine. Is it a machine? Is it a tool? Let's go have a look. So here's what we're going to use. It's the Vevor 40-gallon sandblasting cabinet. Full disclosure, we're not being paid to have this on our channel, but they did send us this at no cost in exchange for us discussing it and showing it on our channel. So that's what we're doing. We're getting ready to use it, and we really need it because otherwise soldering would be tough, a lot tougher than when you have a nice clean surface. So this did arrive in good condition. We unpacked it, nothing was damaged, all the parts were there, the instructions were easy to follow, and it went together without a hitch. Now, I did have a budget sandblasting cabinet years ago, and that's the only one I've had until now. So I'm going to compare it to that. And right away, this is steel. The one I had before was plastic, which in itself was fine, but what ended up happening was we were steady getting shocked by the thing because it was always building up static electricity with all that sand blowing around in the plastic. So I'm looking forward to that. This also came with, I think, 4 extra plastic covers for inside the window. Those are going to wear out pretty quick. They're going to get sandblasted, and so I've got spares, so that's nice. It also came with spare nozzles. They're ceramic, but they're going to wear out before too long, and so spares of those is good as well. We'll take a look inside. One thing I do really like about this is it has these air struts on here which hold the lid open for you. And the one I had before didn't have anything to do that. And you weren't able to fold the lid all the way back, or the hinges would tear out of the plastic. It was just a horrible design. I really like this. This unit has a really bright LED light in it, which I think is great. The last unit we had, which was likely before the invention of LED, had an incandescent bulb off in one corner which didn't throw any light and was always getting sandblasted through, and then you had the 120 volt power supply just kind of loose inside the cabinet, which wasn't ideal. So this one has this nice grate in the bottom, and you can see down here there's a pickup for the glass. We're using recycled glass in this, and there's also an air line for the air supply. And basically you just grab whatever you're going to sandblast, not with your fingertips. You'll blow through them in no time. You want to grab it with an old dead pair of pliers or something and do your sandblasting like that. Sandblaster we had years and years ago had a hole in the back to allow pressure to escape, and of course you're blowing air in, so it's got to go somewhere. And this one has an air filter here. When I first saw this, I was super excited because the one we had before was just always continuously blowing glass all over the shop, the finest of the fine powder. And so I'm interested to see how this works. But I did notice that there's this other hole here, sort of an emergency backup. There's a hole in behind there so that pressure can escape. But of course, grit is going to want to blow out there. So I'm going to monitor that. If it looks like it's becoming an issue, I can hook a vacuum cleaner up, not directly over the hole because you don't want to suck all your glass out, but if I had a vacuum cleaner tube, say here, anything that was wafting out anyways, I could catch with the vacuum rather than breathing it in. Of course, it does recommend a respirator, and of course that's important because inevitably some glass is going to get out of here somewhere, and so you do have to protect yourself with that, and it does say so in the instructions. It did come with this silicone sealant, but nowhere in the instructions did it say what to do with it. Now, I'm assuming that you would probably put that inside of all these joints. But I'm going to try it as is, and if I'm not happy with the way it's working, if I'm getting leaking out these joints, I can always add that at any time. But for now, I'm just going to try it the way it is. Another thing I really appreciated about this was it came complete. The only single thing I had to add to it was the fitting that matches the fittings I have here in my shop. And it did come with a barbed fitting so that if you simply wanted to run a hose into it, you could do that. And in that case, it would have come with every last single thing you need, minus the abrasive grit to get working. So I'm going to pour some grit in here, and we're going to try this thing out for the first time. Well, I've changed my mind. I did go ahead and hook my vacuum up here. I'm pretty much certain from past experience that the finest little bits of dust are going to blow out of this hole, and I just want to catch them. I haven't covered the hole. I'm not wanting to suck the contents of this thing out, but I do want to catch whatever's wafting out of this thing so that we're not breathing it in. I've got my bit held in these old beater locking pliers, and I have access to both of the surfaces I want to sandblast. So those are going in the cabinet, and then I have my roughed out tool bit, and of course I want to sandblast these surfaces, and so that's going in the cabinet. And let's see what happens. Oh yeah, that's mint. Boom, ready. I didn't see any dust come out. I am crazy happy with that. I don't know if you can see here, but those surfaces are great. Those are really, really well prepared for soldering. I will mention you're going to see in our description that there's an affiliate link to Vevor, and should you decide to follow our link and find something there that you like and buy it, well, it won't cost you any extra, but we'll get a little kickback from Vevor, and so that's there if you're interested. So we're all ready for soldering. I've got my little piece of silver here, silver solder. Make sure to get my flux on both surfaces. And it'll find its way around, but still. I've always really enjoyed silver soldering. I find it almost therapeutic. So when that flux starts to melt and heat up, it's going to get real slimy and everything's going to want to slide around. So I have this sacrificial punch, a soldering punch. I'm going to use that to hold everything steady. And I'm going to heat everything but the flux, or the solder, sorry. So I'm going to heat the mild steel tool body, and I'm going to heat the carbide, and I'm going to let them melt the solder. Okay, solder's melting. Now I just want to get that nice and centered up. I think that'll do. So we're going to let that cool down, and then we'll sandblast it off, and we'll make sure we have a good bond, and then we can start grinding our angles into the carbide. This is all cooled down now. Let's have a look at it. So I can already tell that bond is going to be excellent. That solder found its way just everywhere. Every little bit of contact between these two. So we're going to put it in sandblaster, give it a dusting, clean it up. And one of the great things about a sandblaster is that this flux residue is incredibly hard. It won't wire wheel off. It's nasty to even try and file off. Really, it's incredibly tough to get that off, shy of sandblasting. So let's give it a dusting, clean it up, and see how it looks then. Just taking that flux residue off, no problem. There it is after a quick dusting. Still super happy. A little bit of flux residue on there, but that's going to get ground away. And when we grind the form into this, it's entirely possible that there'll be some heat showing up later on the tool. Certainly not enough to melt the flux or solder, but we may want to give this another dusting just to pretty it off, and then in the end, before we say we're done, we'll sharpen it. This is the first of 3 setups to actually put the form on the tool. So we're going to do the same thing basically that we did to the steel body underneath. We're going to grind the 30 degree on the one side with a 6 degree clearance on it. And then we'll flip it around. We'll grind the 30 degree on the other side with the 6 degree clearance the other way. And then we'll sharpen it, and then we'll be done. After a bunch of grinding, I can feel my wheels starting to plug up the slightest bit. And to freshen it up, to clear out its pores, I'm just going to take this aluminum oxide dressing stick and just let it rub on the wheel. And you can see all the black carbide disappearing from out of the wheel. And it's all that fresh diamond there now. Okay, all that's left is to sharpen this guy up and it's done. Now, I am being careful to run my wheel down onto the edge that's going to be doing all the cutting and off of the edge that is going to be doing the scraping. And that's because I want the edge that's going to be doing the cutting to be super sharp, as sharp as it can be, which is what we're going for here. So that's it, guys. It's all sharpened up. You can see it's properly sharp. So there we go. It's all done. It's all sharpened up. Let's pull it out and have a closer look at it. So we've got our 6-degree clearance here and our 6-degree clearance here, and we've got a 3-degree clearance here, and then we've got another 3-degree clearance back this way. And I went ahead and put a tiny little flat on the end. Basically, that's just going to toughen it up a little so it's not so breakable. And this will basically now act as sort of an involute cutter. I'll be able to just sharpen this on the face as it dulls, and it'll maintain all of its features throughout its entire life. Well, that's going to do it for this video, guys. I hope you enjoyed, and thanks for watching. And big shout out to Vevor. I am super happy with the sandblasting cabinet, and we're going to be seeing a lot more of this in the future. Basically, anytime I'm soldering, I'm going here first because that's going to give you your very best results, because it's going to clean your materials to within an inch of their life and give the solder a chance to do its thing.